Welcome to Learning Python with Turtle, Lesson 4. In this video, we're going to see how we can have Python repeat a set of instructions for us using the for command, and also two additional commands that we can provide the turtle. So let's get to it. So from previous videos, we learned that we can draw polygons by providing a combination of forward and lefts with a specific angle. Let's make note that for a triangle, we needed three sets of forwards and lefts in order to draw the triangle. Hopefully that makes sense. Again, if you think about it, each of these lines are drawn by a forward, and then in order to draw the next one in its proper direction, we needed a left. So by combining forward and lefts, we can draw polygons. We saw the same thing with the square, and let's just note we have four sets of these. 1, 2, 3, 4. And again, that should be obvious because in order for us to draw a line, we need a forward. Take a look at our example of a polygon, same thing. We got 1, 2, 3, 4, 5. So you could kind of deduce that for an octagon, we would need to have 8 combinations of forward and lefts with the appropriate angle in order to draw an octagon. Now, when it came to the idea of calculating an angle, again, it might be a little bit challenging for you to try to figure it out, or better yet, we can have Python figure it out. So we've created variables in previous videos to represent the number of sides, and then based off of that value, we were able to calculate the angle because the angle for a polygon to turn using the Python turtle was simply 360 divided by the number of sides. While we were here, we created another variable for the distance, and then we simply, again, this is still a triangle, so we still got 3 sets of these. But at least now, if we wanted to modify the distance, we can do that. If we wanted to have the computer calculate the angle, we can do that. But we will still have to copy and paste another set of instructions if we wanted, let's say, a square or a pentagon. Again, this is where it could get a little cumbersome, which is why we're introducing the for loop. So let's go over to the other example. All right, so the idea is that we don't want to keep repeating instructions. So there is a command that starts with the word for, and this is the same thing for all programming languages. The next thing that follows is a variable. Now I'm going to use the word times for my variable, but honestly, it could be any variable that you want. The next thing is the word in, and notice that the for and the in are in blue, just like the import. These are part of the language, the Python language, so just take note of that. Range 3, because we want to draw a triangle. Also notice that the word range is in a different color, just like the forward lefts. Again, give you another indication that that word is somehow part of the language. So the only thing that you could really change in this line would be the variable and the number of times to repeat an instruction. So for this next part, I'm going to go ahead and delete this and just retype it because I want you to notice what happened at the very end. This is the first time you've seen an instruction that finishes with a colon. That's important. That lets Python know that the next set of instructions are the things it wants you to repeat. So notice here that it's slightly indented. That's also important. That is how Python's able to determine that the next set of commands, which is our forward and lefts, are the commands we want to repeat. Now, I keep saying the word repeat, but I want you to take that to heart. That's actually what the computer is going to do. So this 3 tells Python to repeat these instructions 3 times, which is what we needed for a triangle. So let's try that out. And there's our triangle. Now, we had created a variable called sides, which equals to 3. So we could replace the variable 3 with sides. And notice we still get the same thing, but there's power in that variable. Because now what I can do, I can change the variable to 4, not modify any other part of my code, and I will get a square. Let's see why that happens. Well, if sides is equal to 4, well, the computer's going to Python's going to recalculate the angle to be 90. The for loop now takes that 4 and says, oh, you want me to repeat these instructions 4 times. And that's why we get the square. Because now the number of times these instructions get repeated depends on what we put inside the range. Let's take another one. Let's take a pentagon. Just to prove to you, we're not rewriting code. We're just changing this one variable, and Python knows how many times to repeat this. Again, in previous example, we have to actually copy and paste. Let's do one more. Let's do an octagon for a distance, let's say 50, just so it kind of fits on the screen. So again, a lot of power in this. Let's do one more. Let's do 360, a 360-sided polygon. Hopefully your gut feeling kind of lets you know what is this going to form. So as you're looking, you're probably already figuring it out. Okay, so a 360-sided polygon kind of feels like a circle. And that's essentially what you could do. But there is a much easier way of doing this. And that's what I'm going to show you in the next command. Now, what I'm also going to show you here is, notice if you go to the very last command and press enter, it's still indented, kind of giving you the idea that, okay, it's another set of instructions we want to repeat. At this point, if you want to get out of the for loop, you have to actually go down a line and then press backspace and get it at the same level as the for loop. So let me show you a better way of drawing circles. Nice enough, Python actually has a circle command, which accepts, I believe it's the radius of the circle. So let's do, I don't know, let's do 50. So this is the circle using the for loop, a 300-sided figure. So at this point, we ended the for loop, and there's our circle. So I highly recommend to use the circle command to draw a circle. Don't use the for loop, which, I mean, you could, but again, it takes a lot longer. So we've been talking about polygons. I want to show you something else you could possibly do. Now, I've already executed the program, but I'm going to run it again just to have you feel what it does. So I decided not to use the formula. I just chose a random angle of 138. Any distance is 120, and I'm simply going to repeat the forward and lefts 50 times. So notice, because the angle is not an exact angle to a polygon, the lines are overlapping. And it kind of produces, I don't want to say a spiral, but definitely produces a unique design. But notice it took a little bit for it to draw it. There is a way for us to speed up the turtle. So I'm going to put a 10, and let's see how fast it draws. So hopefully you definitely got the sense it's drawing faster. Now I could give it a speed of 1, and it definitely draws a lot slower. Again, depending on what you're using Python Turtle for, you might want to do it as an animation, which you need to slow down, or you might want to have it as an animation that speeds up. So the range of numbers for the speed command goes from 1 to 10, but here's the awkward thing about this. If you want to have this draw as fast as it could, you would actually enter a number of 0. And what the number 0 really represents is for Bob to draw without animating. So it almost instantly moves to its locations. Let's see that. So hopefully you can definitely appreciate that was fast. So let's go back to our presentation. Let's review what we've done. So in this video, we saw how we can use the for command to repeat a set of instructions. We saw that the for command terminates in a colon, and that the next set of instructions that we want to repeat have to be indented. We also explored 2 additional commands of the turtle, which was speed, which allowed us to speed up the animation of it drawing. And we also saw that there's a circle command if we wanted to draw a circle on the screen. So hopefully you're excited about being able to repeat instructions and enjoy.